Welcome to the Sleepy Brain Dose. You are invited to settle in, to notice the rhythm of your breath, and to let the noise of the day drift softly away. Tonight, we will journey through the solar system, our celestial neighborhood, not with urgency, but with calm curiosity, moving gently from world to world. Allow the words to flow like a quiet tide, guiding you toward rest, while offering small moments of wonder along the way. You may allow yourself to settle, noticing the gentle rhythm of your breath as we begin to explore the vast yet comforting expanse of our cosmic home. When we speak of the solar system, we are describing not only a structure of planets and stars, but also the quiet stage upon which our own lives unfold. It is a neighborhood of immense scale, yet within that scale, there is a deep sense of rhythm, order, and continuity that has guided life on Earth for billions of years. The solar system is centered on a single star, our Sun. Around this point, of steady light and warmth, planets, moons, asteroids, and comets trace their slow, predictable paths. From a human perspective, these distances can feel unimaginably large. Yet from another angle, the solar system can be seen as intimate, a single family of bodies bound together by gravity, moving in harmony like dancers in an unhurried circle. This idea that everything moves together in balance can be soothing, reminding us that even within immensity, there is stability. If you picture the solar system as a vast disk, with the Sun at its center, you may notice that most of the planets orbit in nearly the same plane. This plane is called the ecliptic, and it creates a sense of order, as though the planets are beads sliding slowly along invisible threads. The Earth, our home, is one of these beads, positioned at just the right distance where warmth and light create an environment that can sustain life. The regularity of this orbit means that seasons return, day follows night, and life finds a rhythm in step with the cosmos itself. Distances in space are so great that ordinary measures lose their meaning. We do not speak of kilometers or miles when describing the vastness between planets. Instead, we use astronomical units, with one unit equal to the distance between Earth and the Sun. Even then, the numbers can feel overwhelming. Mercury, the closest planet, lies only a fraction of an astronomical unit away. Neptune, on the farthest frontier of the planetary system, orbits at a distance of nearly 30 astronomical units. Beyond Neptune, the Kuiper Belt and the imagined cloud of comets expand this neighborhood even farther, stretching into a darkness that seems endless. And yet, despite this immensity, the gravitational embrace of the Sun holds it all together, like a gentle thread stitching each world into place. When we look outward into the solar system, we are not only considering a map of distances, we are also seeing layers of history. The Sun itself is more than 4.5 billion years old, and the planets formed soon after, condensing from a swirling disk of gas and dust. In the quiet of night, when you glance at the stars, you are gazing at reminders of this process, matter drawn together, shaped by gravity, and set into motion. To know that Earth shares this origin with all other planets can bring a feeling of belonging, not just to a planet, but to a larger family of celestial companions. Our solar system is located within one arm of the Milky Way galaxy, a vast spiral of hundreds of billions of stars. From Earth's surface, we see this galaxy as a pale band stretching across the night sky, a river of light softly flowing through darkness. The fact that we are part of both a local solar system and a greater galactic environment can feel overwhelming. Yet it can also be deeply grounding, a reminder that we are not isolated, but woven into an immense fabric of stars. The solar system is our local address, a small but essential part of the Milky Way, which itself is one galaxy among countless others. To recognize this perspective can bring both humility and calm. You may notice that the solar system is not chaotic. The orbits of planets, moons, and other bodies follow predictable paths, and these paths repeat with gentle patience. Earth's year is one orbit of the sun, and that orbit repeats with steady regularity. The moon's phases return in cycles, guiding tides, and calendars. Even the more irregular travelers, such as comets, still obey the same gravitational laws. This predictability is a gift to our sense of safety. It reminds us that even though the cosmos is vast, it is also steady, offering a framework in which life can unfold in continuity. When we call the solar system a neighborhood, it is because it shares qualities with the places we know on Earth. A neighborhood is a set of homes, a network of paths, and a sense of community. In space, the sun is the central source, and the planets are like houses arranged along gentle lanes of orbit. Some homes are close, like Mercury and Venus, clustered near the sun's warmth. Others are more distant, like Uranus and Neptune, resting on the far edges of this great neighborhood. Yet all remain part of the same connected whole, each orbit tied to the same center, each journey predictable and slow. The solar system also offers balance between extremes. Closer to the sun, planets experience intense heat, while farther away, they receive only faint light. In between lies a band known as the habitable zone, where conditions allow liquid water to exist. Earth happens to orbit within this zone, which is why life could take root here. To reflect on this balance can feel comforting. It is as though the cosmos has provided a gentle cradle for life, a space where warmth and coolness meet in harmony. Knowing this, one might sense a quiet gratitude for the conditions that allow us to be here, breathing, observing, and resting. You may imagine the solar system as both immense and approachable. Immense because the distances between planets are measured in millions and billions of kilometers. Approachable because the same patterns repeat again and again, offering familiarity. Day after day, the sun rises and sets. Season after season, Earth turns and tilts, creating cycles of light and growth. Year after year, the planets trace their orbits, always returning, never lost. This continuity can mirror the rhythm of breath itself, expansion and contraction, in and out, light and shadow, all repeating in calm succession. It is natural, when thinking about space, to feel a sense of awe at its scale. But awe does not have to be overwhelming. It can also be gentle, like standing by a calm sea that stretches beyond sight. The solar system is vast, yes, but it is also home. It is the environment in which our Earth rests, the source of the cycles that guide our days and nights, and the context within which life unfolded. To consider our place in space is not to feel small, but to feel connected to a larger order. It is to recognize that even within immensity, there is belonging. The solar system holds mysteries we continue to study. Yet what we already know is enough to bring comfort. The sun will continue to shine for billions of years. The planets will continue to orbit, their paths stable and steady. Earth will continue its cycles of day and night, season and renewal. And within these cycles, we can find peace, the peace of knowing that our lives, brief as they may be, are supported by an ancient and enduring rhythm. So, as you reflect on our place in space, you may notice the soft rhythm of your own breathing, rising and falling like the orbits of planets. You may allow yourself to rest in the awareness that you are part of a greater whole, safe within a cosmic neighborhood that has existed long before us and will continue long after. In this recognition, there is calm. In this perspective, there is softness. And in this shared home, there is room for rest. The sun is the heart of our solar system, the steady source of light and warmth that allows life on Earth to exist. When we think of the sun, it can be easy to picture only the bright orb that rises each morning and sets each evening. Yet behind this simple image lies a profound truth. The sun is a star, immense and enduring, sustaining every rhythm of life we know. To understand the sun is to understand why Earth is alive, why the solar system holds together, and why our days and seasons unfold in the patterns we experience. The sun formed about 4.5 billion years ago, condensing from a swirling cloud of gas and dust. Within this cloud, gravity drew matter inward until the pressure at the center grew so intense that nuclear fusion began. Fusion is the process that powers the sun still today. Deep in its core, hydrogen atoms are pressed together under immense heat and density, merging into helium and releasing energy in the process. That energy travels slowly outward, taking thousands of years to reach the surface, and then streams across space as light and warmth. Every ray of sunlight you feel on your skin is the result of countless reactions, occurring unceasingly in the sun's core, woven into a steady rhythm that has endured for billions of years. The scale of the sun is almost beyond comprehension. It is so large that more than 1 million Earths could fit inside it. Its mass accounts for more than 99% of the total mass of the entire solar system. This immense gravity holds the planets in orbit, guiding their paths in stable loops around the central star. Without the sun's pull, Earth would drift into cold, empty space. Without the sun's light, Earth would be frozen and dark. The sun is not just part of the solar system. It is the anchor that makes the solar system possible. On Earth, the sun defines the rhythm of time. A single day is one rotation of Earth relative to the sun. A year is one orbit of Earth around the sun. Seasons are created by the tilt of Earth's axis as it circles, bringing varying angles of sunlight across the surface. When we wake in the morning, when crops grow in summer, when leaves fall in autumn, all of these are reflections of Earth's relationship to its star. In this way, the sun becomes not only a physical presence, but a symbol of continuity. Its rising and setting shape the rhythm of our lives, linking our breath and activity to the steady pulse of the cosmos. Though the sun is powerful, its light reaches us gently. After traveling 150 million kilometers, the energy that began as nuclear fire in the core spreads out into warmth that nourishes plants, heats oceans, and allows life to thrive. Plants use this energy in photosynthesis, transforming sunlight into food that sustains entire ecosystems. Animals, including humans, depend on this chain of energy. Every meal we eat is, in some way, sunlight transformed into nourishment. 2. Reflect on this can bring a sense of calm gratitude. The warmth that touches your skin, the food that sustains you, the cycles of growth and renewal, all are gifts from the steady burning of a star. It is natural to wonder how such a star can continue burning for billions of years without fading. The answer lies in balance. The sun's gravity pulls inward, compressing its matter. At the same time, the energy of fusion pushes outward. These two forces, gravity and fusion, balance each other, creating a state of equilibrium. It is this balance that gives the sun its stability. For humans, stability often brings peace, and to know that the sun is stable can feel deeply reassuring. Scientists estimate that the sun is about halfway through its life, with billions of years still to come. This means that for countless generations ahead, the sun will continue to rise, providing light, warmth, and rhythm. The sun is not perfectly calm, however. Its surface, called the photosphere, is a sea of activity. Dark spots, known as sunspots, appear where magnetic fields twist and concentrate. Bright flares release bursts of energy that ripple outward through space. Yet even these events are part of a greater cycle, a rhythm of about 11 years during which solar activity increases and then subsides. These cycles, though powerful, do not disturb the sun's essential stability. Instead, they remind us that even in constancy, there is variation, like the gentle waves of breath, rising and falling without breaking the pattern of life. Beyond light and warmth, the sun also sends out a constant stream of particles known as the solar wind. This wind flows through the solar system, carrying with it magnetic energy. When it reaches Earth, our magnetic field shields us, guiding many of the particles toward the poles. There, they create auroras, curtains of light that shimmer in the sky, reminders of the sun's quiet influence reaching across space. To watch such an aurora is to feel awe, but also to sense connection, a direct link between the activity of the sun and the beauty of the night sky. Culturally, the sun has always been central to human understanding. Ancient civilizations worshipped it as a deity, recognizing its role in sustaining crops and life. Calendars were built around its cycles. Rituals honored its rising and setting. Even today, when we understand the sun scientifically as a star, it still holds symbolic meaning. It is light in darkness, warmth in cold, continuity in change. To reflect on the sun is to reflect on what steadiness means in our own lives, the comfort of rhythm, the reassurance of cycles, the calm of something greater than ourselves, continuing without interruption. When you observe the sun, even indirectly, you are not only looking at a bright disk in the sky, you are witnessing the heart of our planetary system, the rhythm that beats through every living thing on Earth. Each sunrise is a renewal, each sunset a pause, each season a movement in this long dance of orbit and light. To know this can bring ease. It can soften the sense of time passing too quickly, reminding us that we move within cycles that are ancient and enduring. As you breathe slowly, you may notice how the rhythm of your body echoes the rhythm of the sun's gift. Inhale, like the arrival of dawn. Exhale, like the quiet of dusk. In this way, the sun's light does more than sustain life. It aligns us with the universe. Our place in space is not random, but deeply tied to this star, whose steady presence creates both the environment for life and the rhythm that shapes our days. And so, when you think of the sun, you may allow yourself to feel not only awe, but also comfort. It is immense, yes, and powerful, but it is also steady and kind. Its warmth has touched Earth for billions of years, and will continue to do so long into the future. Its cycles of light and shadow, activity and calm, mirror the cycles within ourselves. The sun is our source of light, our measure of time, and our constant companion in the vastness of space. To rest in that awareness is to rest in safety, rhythm, and peace. Mercury is the first planet from the sun, the swiftest traveler in our solar system, and yet, in many ways, also one of the quietest. Because it is so close to the sun, Mercury completes one orbit in just 88 Earth days. From our perspective, it seems to hurry around its path, circling nearly 4 times for every single year we experience on Earth. This swiftness gave the planet its name in ancient times, associated with the messenger god, a figure of speed and movement. But if you take a closer look, Mercury is not restless. It moves in silence, keeping to its orbit with calm regularity, always present in its role as the innermost companion of the sun. Mercury is small, only slightly larger than Earth's moon. If you could place Mercury next to our world, you would see how modest it is in size, a quiet neighbor on the edge of the sun's intense light. And yet, despite its smallness, Mercury holds remarkable lessons. It shows us how a planet adapts to extremes, how a world closest to a star can find its balance, and how motion itself can be steady and reliable, because Mercury is so close to the Sun. Its surface experiences dramatic contrasts in temperature. In daylight, the surface can rise to more than 400 degrees Celsius, hot enough to melt many metals. At night, with no thick atmosphere to retain heat, the temperature drops far below freezing, colder than most places on Earth could ever be. This contrast reminds us that proximity to warmth does not always mean comfort. Without a blanket of air like Earth's, Mercury cannot soften the extremes. And yet, Mercury continues its path, enduring both heat and cold, cycling day into night. In patient rhythm, a day on Mercury, measured from one sunrise to the next, is unusual. Because of the way the planet rotates and orbits, a full day lasts 176 Earth days. This means that on Mercury, the sun seems to rise very slowly, climbing across the sky with great patience before setting again months later. In some regions, the sun even appears to pause or move backward briefly before continuing its path. This strange rhythm shows how varied time can feel depending on where you are in the solar system. While Mercury races around the sun, its rotation slows the experience of day and night, creating a paradox. The swiftest planet also has some of the longest days. Looking at Mercury's surface, we see a world marked by craters, ridges, and cliffs. Its landscape resembles that of our moon, with scars left from countless impacts over billions of years. Large basins reveal where ancient collisions shaped the terrain, while long cliffs, called scarps, stretch for hundreds of kilometers, evidence of a planet that has slowly cooled and contracted. These features speak of history, of time passing, not in years or centuries, but in eons. Mercury may seem quiet now, but its surface tells a story of a restless past, when the solar system was still forming and collisions were common. To reflect on this history can be calming, because it reminds us that change slows down. What was once chaotic eventually becomes ordered, and even a battered surface can find stillness. Though Mercury is close to the sun, it is not easy to see. The planet is often hidden in the sun's glare, visible only at dawn or dusk when it rises just before the sun or sets just after. For this reason, many people have never noticed Mercury with their own eyes. And yet, when it does appear, it shines with a steady light, a tiny beacon of the innermost orbit. To catch sight of Mercury is to be reminded of how much exists quietly, without drawing attention. Just because something is not always visible does not mean it is absent. Like a gentle breath, Mercury continues its path whether we watch or not. Mercury has no moons. It travels alone, without a companion circling its surface. This solitude may seem stark, especially compared to Earth and its close relationship with the moon. But there is a kind of peace in this aloneness. Mercury is part of the greater solar system family, bound by gravity to the sun, yet it does not need a satellite to confirm its presence. It simply follows its orbit, steady and solitary, a reminder that companionship can take many forms, and that sometimes being part of a larger whole is enough. Scientists have visited Mercury through space probes, most notably Mariner 10 in the 1970s and the Messenger mission in the early 2000s. These spacecraft revealed the planet's surface in detail, mapping craters and measuring its magnetic field. They showed that Mercury, though small, has an iron core that creates a magnetic field, one of the few rocky planets to do so. This discovery surprised researchers because such a small planet was not expected to maintain this feature. It is another reminder that even the smallest worlds can hold unexpected strength. For us, it can be a lesson in humility and wonder, not to judge significance by size, and to remain open to what each world or each moment may reveal. The orbit of Mercury is slightly elongated, not a perfect circle, but an ellipse. Over centuries, scientists noticed that its orbit shifted in ways Newton's laws could not fully explain. This mystery puzzled astronomers until Einstein's theory of general relativity provided the answer. Mercury's motion, influenced by the sun's intense gravity, confirmed the predictions of relativity and helped prove one of the most important ideas in modern physics. Yet beyond the equations and discoveries, there is something calming in this fact. Mercury, by simply moving as it always has, became a messenger not only of speed but of knowledge. In its quiet orbit, it taught us something profound about the nature of space and time. To reflect on Mercury is to reflect on extremes and endurance. It is a planet of contrasts, hot and cold, swift and slow, visible and hidden. Yet within these contrasts, it continues steadily, without complaint, without interruption. It shows us that balance is not always comfortable, but it can be stable. It shows us that even in the harshest conditions, a rhythm can persist. And it shows us that even the smallest bodies in space play a vital role in the harmony of the whole. As you picture Mercury, you may allow yourself to feel its quiet perseverance. A small world, circling swiftly, enduring heat and cold, yet steady in its path. It does not need to shine brightly in our sky to matter. It does not need to be large to hold significance. It simply moves, following its orbit, keeping its rhythm, teaching us by example that even the swiftest wanderer can embody calm. And in that recognition, you may find your own rhythm softening. Your breath continues in its steady cycle, like Mercury's orbit around the sun. Inhale, like the rising of the planet into dawn. Exhale, like its slow descent into night. Within this rhythm, there is balance, and within that balance, there is peace. Venus is often called Earth's twin. At first glance, this description feels accurate. The two planets are similar in size, in mass, and in composition. If you place them side by side, they would appear like siblings, nearly matching in diameter and density. But beyond these surface similarities, Venus reveals itself to be a world of contrasts. It is a planet wrapped in mystery, hidden beneath a thick blanket of clouds, and shaped by conditions that are both extreme and fascinating. To reflect on Venus is to reflect on what it means to resemble another closely, and yet to follow a very different path. From Earth, Venus is one of the brightest objects in the sky. It shines at dawn or dusk, earning the names morning star and evening star. Its brilliance comes not from its own light, but from the way its thick clouds reflect the sun. When you see Venus glowing near the horizon, you are not seeing the surface of the planet, but the gleam of sunlight bouncing off a veil of atmosphere. This brightness has inspired cultures for thousands of years, guiding calendars, poetry, and myth. And yet, the same clouds that make Venus so radiant also conceal it. For centuries, humans could not see beneath the shroud, unable to know what the surface was truly like. The atmosphere of Venus is one of its most striking features. It is composed mostly of carbon dioxide, with clouds of sulfuric acid drifting through its dense layers. This atmosphere is so thick that the pressure at the surface is over 90 times greater than on Earth, the equivalent of being nearly a kilometer beneath the ocean. To stand on Venus would be to experience a crushing weight all around you, though, of course, no human has ever done so directly. The thick blanket also traps heat in a process called the greenhouse effect. As a result, Venus is the hottest planet in the solar system, even hotter than Mercury. Despite being farther from the Sun, temperatures on the surface reach nearly 500 degrees Celsius, hot enough to melt lead, hot enough to make the entire planet an oven under its permanent clouds. Because of this heat and pressure, Venus is not a place where life as we know it could exist. Yet to understand its atmosphere is to understand more about our own. The extreme greenhouse effect on Venus is a reminder of the delicate balance that makes Earth habitable. On our planet, greenhouse gases keep warmth in, preventing us from freezing. On Venus, the same process has gone to an extreme, transforming the planet into a furnace. To reflect on this contrast can feel humbling. Two planets alike in size, yet one is a cradle for life, while the other is a world of heat and haze. The surface of Venus, mapped by radar from orbiting spacecraft, reveals a world of volcanoes, mountains, and plains. More than 80% of the surface is covered by volcanic rock. Some volcanoes appear immense, stretching across hundreds of kilometers. There is evidence that volcanic activity may have reshaped large areas of the planet relatively recently in geological terms, though the details are still being studied. The surface also features vast plains, ridges, and highland regions, hinting at a restless past hidden beneath the clouds. Unlike Earth, Venus does not have plate tectonics as we know them. Its crust seems to act more like a single shell, shifting in different ways. These differences remind us that even planets of similar size can evolve with very different geologies. Time on Venus flows in a peculiar rhythm. A day on Venus, defined by one rotation on its axis, lasts longer than its year. It takes 243 Earth days for Venus to rotate once, while it takes only 225 Earth days to orbit the Sun. This means that a Venusian day is longer than its year. To add to the strangeness, Venus rotates in the opposite direction to most other planets, including Earth. On Venus, if you could stand on the surface, the Sun would appear to rise in the west and set in the east. These slow and reversed cycles create a sense of disorientation from an earthly perspective, but also an opportunity for reflection. Time is not absolute across the solar system. It bends and shifts depending on where you are. Venus teaches us that rhythm can be measured differently, and that what feels slow in one frame may feel swift in another. Despite its harsh surface, Venus has winds high in its atmosphere that race around the planet at tremendous speeds. These winds can circle the globe in just 4 Earth days, moving far faster than the rotation of the planet itself. As a result, the clouds of Venus shift and swirl in constant motion, while the ground beneath remains hidden in its slow, hot stillness. This contrast, stillness below, movement above, can be a gentle metaphor. Even in places where the surface is unchanging, there may be currents flowing just beyond sight. Venus holds both slowness and swiftness within its layers, a reminder that rhythm can exist in many forms at once. Humanity's attempts to reach Venus have been both ambitious and challenging. The Soviet Union's Venera missions were the first to land on the surface, sending back brief transmissions before being silenced by the intense heat and pressure. These landers revealed rocky plains and orange skies, confirming that the surface was as extreme as scientists suspected. Later missions, such as NASA's Magellan spacecraft, used radar to map the planet in detail, peeling back the layers of cloud to reveal its hidden face. These missions brought Venus closer to us in knowledge, even if not in presence. They showed that even the most shrouded worlds can be understood with patience and curiosity. Culturally, Venus has long been associated with beauty and love. Its brilliance in the sky inspired its name, linked to the Roman goddess of love. There is a poetic irony in this. A planet named for beauty and gentleness is, in reality, one of the harshest places in the solar system. Yet perhaps this irony holds a lesson. Beauty does not always mean softness. Radiance can conceal difficulty. And even the most inhospitable worlds can shine with striking light. When viewed from afar, to think of Venus is to think of mystery and revelation. For centuries, it appeared as a glowing star, its surface unknowable. Slowly, with technology and patience, humanity uncovered its secrets. Yet even now, Venus holds questions about its volcanic history, about the possibility of rare chemistry in its clouds, about the long path that made it so different from Earth. In this way, Venus remains a teacher, inviting us to explore not only what is visible, but what lies beneath the surface. As you picture Venus, you may allow yourself to feel both its brightness and its distance. It glows like a lantern in the sky, steady and beautiful. Yet behind that glow is an environment of extremes, hidden and separate. To reflect on this is to remember that appearances are only part of truth, and that mystery itself can be calming. The clouds of Venus remind us that not everything needs to be seen clearly. Some things can remain veiled, and in that veiling there can be serenity. So as your breath continues in its steady rhythm, imagine Venus circling the sun, wrapped in its shroud of clouds. Swift winds sweep its skies, while the surface endures in heat and stillness. Earth may be its twin in size, but Venus has followed its own path, showing us another possibility of planetary life. To rest with that thought is to rest with diversity, with the knowledge that the universe holds many forms, each with its own rhythm. And in the quiet reflection of Venus, the shrouded twin, you may find calm, softness, and peace. Among all the planets of the solar system, Earth is the one that feels most familiar, because it is our home. It is the ground beneath our feet, the air we breathe, the oceans that stretch beyond the horizon, the forests and deserts and mountains that define our landscapes. And yet, when viewed from space, Earth becomes something entirely different. A small, blue sphere suspended in the vastness, delicate and shining, a single oasis in a wide expanse of darkness. To reflect on Earth is to reflect on the rare balance that makes life possible, and to recognize the gentle rhythms that connect us to the larger universe. Earth is unique because it has the right conditions for life. Positioned within the sun's habitable zone, it receives enough warmth to prevent freezing, but not so much that water boils away. This balance allows liquid water to exist on the surface, and water, in turn, is essential for life. More than 70% of Earth's surface is covered by oceans, seas, and lakes. These waters are not just features of the landscape. They are the lifeblood of the planet. They circulate heat, shape weather, and nurture countless forms of life. 2. Imagine Earth without its oceans is to imagine a world stripped of vitality. The presence of water makes Earth a living world, vibrant and ever-changing. The atmosphere is another gift. Earth's air is a mixture of nitrogen, oxygen, carbon dioxide, and trace gases, wrapped like a soft blanket around the planet. This blanket shields us from harmful radiation, burns away meteors before they strike the surface, and keeps warmth close enough to sustain life. The atmosphere also creates the sky we see each day. Its scattering of sunlight turns the heavens blue, and its layers reflect hues of red, orange, and purple at sunrise and sunset. Beyond the colors, the atmosphere carries the very breath we depend on. Each inhale you take is possible because of the air that encircles the globe. This connection between atmosphere, breath, and life is a quiet reminder of how deeply we are tied to the planet. Earth's surface is dynamic, shaped by plate tectonics, the slow movement of massive plates of rock that float on the molten mantle beneath. These movements build mountains, open oceans, and create earthquakes and volcanoes. Though such processes can sometimes seem violent, they are also signs of a living planet, constantly reshaping itself. The crust of Earth is not static. It shifts over millions of years, recycling rock, renewing landscapes, and maintaining a balance that influences climate and life. In this way, Earth is not a still object, but a breathing, evolving system. Its changes mirror the cycles we see in ourselves: growth, renewal, transformation, and rest. The diversity of life on Earth is unmatched. From single-celled organisms to forests teeming with plants and animals, life adapts to nearly every environment. Deep oceans harbor creatures that never see sunlight. Deserts hold species that survive with almost no water. The poles, covered in ice, are home to birds, mammals, and microorganisms. This abundance of life reminds us that Earth is not just a planet of rock and water, but a planet of relationships, webs of connection where each form of life supports another. To reflect on this can feel soothing, because it shows us that interdependence is natural, and that even in vast variety, harmony is possible. When astronauts first saw Earth from space, they described a feeling known as the overview effect. Looking back at the planet, they saw not borders or divisions, but a single fragile sphere, glowing blue and white against the blackness. They spoke of awe, of unity, and of responsibility. From a distance, Earth is not divided into nations. It is one home shared by all. To imagine this view can bring perspective. The conflicts and concerns that seem so large from the ground become smaller when seen against the backdrop of space. What remains is beauty, delicacy, and connection. The rhythms of Earth also shape our lives. The rotation of the planet creates day and night, giving us cycles of activity and rest. The tilt of its axis creates seasons, guiding the growth of plants, the migrations of animals, and the traditions of cultures. These rhythms are not accidental. They are steady patterns that life has adapted to for millions of years. When you notice the rising of the sun, the lengthening of days in summer, or the quiet of winter, you are noticing the planet's gentle turning. These cycles bring reassurance, a sense that change is natural, and time moves with purpose. Earth is also protected by invisible shields. Its molten core generates a magnetic field that extends into space, deflecting solar wind and cosmic radiation. Without this field, the atmosphere might have been stripped away, leaving Earth bare and uninhabitable. Instead, the magnetic field acts like a quiet guardian, unseen but essential. Occasionally, when solar particles interact with this field, they create auroras near the poles, dancing lights in the night sky. These displays are not just beautiful. They are reminders of the hidden protections that allow life to thrive here. The landscapes of Earth are endlessly varied. Towering mountains rise where tectonic plates collide, while deep trenches mark the places where one plate slides beneath another. Rivers carve valleys, glaciers sculpt plains, and winds shape dunes. Each feature is part of a story written over billions of years. To stand within such a landscape is to be part of that story, connected to processes far older and slower than a human life. This awareness can bring calm because it places our brief existence within a larger, ongoing narrative of change and renewal. Culturally, Earth has always been revered. Myths across the world speak of the planet as a mother, a source of life and sustenance. Farmers watched the sky to know when to plant crops. Sailors studied the stars to guide their journeys, and entire civilizations rose and fell in relationship to the land. Even today, with satellites and technology, we remain deeply dependent on Earth's cycles. Food, water, shelter, and energy all come from this planet. To reflect on this dependence is not to feel small, but to feel gratitude for the intricate system that sustains us. Earth is rare in another way. It is the only known world with life. Astronomers have discovered thousands of exoplanets orbiting distant stars. Some may hold water, some may lie in habitable zones, but none has yet revealed the richness of Earth. Until we know otherwise, Earth remains unique, the sole cradle of life in the universe that we can see. This rarity adds to its value. To know that we are part of something so rare is to know that we are part of something precious. As you reflect on Earth, you may notice the rhythm of your own breath once again. Each inhale is drawn from the planet's air. Each sip of water is part of a cycle that has moved through oceans, clouds, and rivers for billions of years. Each bite of food is energy that began as sunlight, captured by plants, and passed through the web of life. To be alive is to be connected to Earth in countless ways. These connections are not burdens, but gifts, threads that tie us gently to our home. And so, when you imagine Earth from space, glowing softly against the darkness, you may allow yourself to feel both wonder and comfort. This is our living home, balanced in its orbit, wrapped in its atmosphere, renewed by its rhythms. It has carried life for billions of years, and it continues to do so now. To rest with this thought is to rest with security, knowing that Earth is not only our home, but a sanctuary in the vastness of space. The moon has been with Earth for as long as humanity has looked up at the night sky. It is our closest celestial neighbor, circling us in a rhythm so steady that its presence has become a part of the fabric of life itself. When you see the moon rising above the horizon, glowing softly against the darkness, you are not only witnessing a natural satellite, you are seeing a companion that has moved with Earth for more than 4 billion years, shaping the planet, guiding cycles, and inspiring reflection. To think of the moon is to think of constancy, of rhythm, and of a gentle companion that has never strayed far from our side. The origin of the moon is tied deeply to Earth's own history. Scientists believe it was born from a great collision. In the early solar system, when a Mars-sized body struck the young Earth, the debris from that impact gathered in orbit and eventually formed into a sphere, becoming the moon we know today. This beginning may sound violent, but out of that collision came stability. Since then, the moon has circled Earth, providing balance to its tilt, slowing its rotation, and influencing the rhythms of oceans and life. In this way, the moon is not only a companion, but a partner in Earth's story, shaping its evolution with quiet persistence. The moon's orbit is steady, completing one circuit around Earth in about 27 days. This motion creates the phases we see from the ground: the waxing crescent, the full moon, the waning gibbous, and the dark new moon. These phases are not illusions, but reflections of the sun's light shifting across the lunar surface as the moon moves in its orbit. To watch the phases is to watch a cycle of light and shadow, always repeating, always returning. This rhythm has guided humans for millennia, inspiring calendars, rituals, and myths. It reminds us that time flows in cycles, not only in straight lines, and that each return is both familiar and renewing. The moon also exerts a physical influence on Earth. Its gravity pulls on our oceans, creating tides that rise and fall in gentle rhythm. Twice each day, Waters move in response to this pull, shaping coastlines, nourishing ecosystems, and influencing patterns of life. Without the moon, Earth's tides would be faint, and many coastal environments would not exist as we know them. The regular rise and fall of the sea is one of the most tangible ways we experience the moon's presence, even if we cannot always see it in the sky. To notice the tide is to notice the moon's hand, stretching across space, linking us to our Earth. Companioned through invisible threads of gravity, beyond tides, the moon stabilizes Earth's tilt. Our planet is tilted on its axis at about 23 degrees, a tilt that creates the seasons. Without the moon's steadying influence, that tilt might wobble more dramatically over time, leading to chaotic changes in climate. The moon's gravitational pull keeps Earth's tilt within a narrow range, maintaining the stable rhythm of seasons that life has adapted to. This quiet guardianship is easy to overlook, but it is profound. The moon does not only light the night. It helps ensure that Earth remains a place where life can flourish. When you look at the surface of the moon, even with the naked eye, you see patterns of light and dark. The lighter areas are highlands, ancient and heavily cratered. The darker patches are vast plains of cooled lava, known as Maria. These plains were formed by volcanic activity billions of years ago, when impacts created basins that later filled with molten rock. The craters, meanwhile, are scars from countless collisions with asteroids and comets. Together, they create a record of the solar system's history, preserved in silence. Unlike Earth, where weather and tectonics erase old features, the moon's surface holds onto its past. Every crater and ridge is a memory, a reminder that time stretches far beyond human scales. The moon has no atmosphere as we know it, no air to scatter light or to soften the harshness of day and night. On its surface, temperatures swing from extreme heat to deep cold, just as they do on Mercury. And yet, even without air or weather, the moon holds fascination. Its silence and stillness make it seem eternal. To imagine standing on its surface is to imagine a place without sound, without wind, with only the Earth hanging above in the black sky. For astronauts who have walked there, this view was humbling. To see their home planet glowing blue and alive against the darkness, while standing on a world barren and quiet, the moon has always carried meaning in human culture. It has been the calendar for farmers, marking the time to plant and harvest. It has been a symbol in stories, representing cycles of birth, death, and renewal. It has been a guide for travelers, casting light on paths at night. Poets and artists have drawn inspiration from its glow, seeing in it mystery and reflection. Even today, in a world filled with electric light, the sight of the moon can evoke calm. To look up at a full moon is to feel connected not only to the sky, but also to generations who looked at the same light long before us. Though the moon is constant, it also drifts slowly away. Each year, it moves a few centimeters farther from Earth as tidal interactions transfer energy between the two bodies. Over billions of years, this drift will change the length of Earth's day and the appearance of eclipses. But for now, and for countless generations to come, the moon remains steady, circling us in its familiar path. To know this is to know that constancy can include change, and that even as things shift slowly, they remain connected. Eclipses are among the most striking interactions between Earth, the moon, and the sun. When the moon passes between Earth and the sun, it casts a shadow, creating a solar eclipse. When Earth comes between the sun and the moon falls into shadow, creating a lunar eclipse. These events are rare and temporary, but they reveal the precision of the cosmic dance. The alignments are not random but predictable, showing that even great distances and movements obey a rhythm. Watching an eclipse can feel dramatic, but it can also feel reassuring. Even unusual events follow patterns, and those patterns repeat in time. God's scientific exploration of the moon has deepened our connection to it. The Apollo missions of the 1960s and 70s brought humans to its surface, allowing them to walk, collect rocks, and leave instruments behind. These missions showed us not only what the moon is made of, but also what Earth looks like from afar. Photographs like the famous Earthrise changed perspectives, reminding us of our planet's fragility and beauty. Today, new missions are planned with hopes of returning to the moon and even building habitats there. Yet beyond exploration, the moon remains what it has always been, a constant presence, steady in its orbit, patient in its cycles. As you picture the moon, you may allow yourself to feel its rhythm. The phases waxing and waning, the tides rising and falling, the seasons steadied by its pull. The moon is always there, whether visible or hidden, circling us in silence. It does not demand attention, yet it offers guidance. It does not change quickly, yet it shapes life profoundly. To rest in this awareness is to rest with companionship, knowing that we are never alone in space. And so, as your breath moves in and out, like the slow rising and falling of tides, you may imagine the moon above, glowing softly. It is our constant companion, a witness to Earth's history, a partner in its balance, and a light in the night sky. Its presence is gentle, steady, and enduring. In the quiet reflection of the moon, you may find calm, rhythm, and peace. Mars has long held a special place in human imagination. It is our neighbor in the solar system, orbiting just beyond Earth, and it is a world that feels both familiar and distant. From the ground, Mars appears as a reddish star in the night. Sky steady in its path, sometimes shining brightly, sometimes fading into the background. Its color gave rise to myths of fire and war, but beneath those associations lies a world of silence. Mars is not a place of conflict or noise, but a quiet frontier, a planet shaped by dust, rock, and time. To reflect on Mars is to reflect on both possibility and patience. Mars is smaller than Earth, about half its size, yet large enough to hold continents, mountains, and valleys. Its surface is marked by striking features, many of them immense by earthly standards. The planet's color, a rusty red, comes from iron oxide, the same substance we call rust, covering its soil and rocks. When sunlight touches Mars, this dust reflects back a soft, reddish glow. The appearance is simple, but it holds a sense of calm. A planet bathed in red light, silent and cold, moving through its orbit with steady rhythm. The atmosphere of Mars is thin, less than 1% the density of Earth's, composed mostly of carbon dioxide, with traces of nitrogen and argon. It cannot provide the warmth or protection we experience on Earth. Because of this, temperatures on Mars swing widely, often dropping far below freezing, even at midday. The thin air also means that liquid water cannot last on the surface for long. It evaporates or freezes quickly. And yet, signs of water are written across the landscape. Ancient riverbeds, dry deltas, and layered sediments show that long ago, Mars held flowing water. At the poles, sheets of ice remain, hidden beneath dust. The presence of this water tells a story. Mars was once more active, perhaps warmer, perhaps capable of supporting conditions that life could have known. Among Mars's most striking features is Olympus Mons, the largest volcano in the solar system. It rises nearly 3 times higher than Mount Everest and spans a region the size of France. To imagine such a mountain is to imagine scale beyond human experience. Yet Olympus Mons is not active today. It rests in silence, a monument to a time when Mars was geologically alive. Nearby lies Valles Marineris, a canyon system stretching over 4,000 kilometers, as long as the entire continent of the United States. Its cliffs and valleys are reminders of forces that once shaped Mars with energy and movement. Today, these features remain, quiet and unmoving, preserved in the thin atmosphere. They speak of a world that has slowed, a frontier that holds its past gently on its surface. Mars has two small moons, Phobos and Deimos. Unlike Earth's large, steady moon, these companions are irregular, rocky shapes, perhaps captured asteroids. From long ago, they circle Mars quickly, tiny shadows in the sky. Phobos, the larger of the two, orbits so close that it rises and sets multiple times in a single day. Over time, it is slowly drawing nearer to Mars and will eventually break apart. Deimos, smaller and more distant, orbits with more patience. These moons are reminders that companionship can take many forms, and that even the quietest worlds have partners in their journey. Seasons exist on Mars, much like Earth, because its axis is tilted at a similar angle. As Mars orbits the Sun in its longer 687-day year, polar ice caps grow and shrink, dust storms shift across the surface, and the planet breathes in its own rhythm of change. Sometimes dust storms engulf the entire planet, covering it in a haze of red for weeks or months. These storms may sound dramatic, but from the surface, they are more like a steady dimming of light than a violent event. The winds lift fine dust into the thin air, creating a veil that softens the planet's features. Even here, in what might seem harsh, there is gentleness. A planet wrapped in quiet storms, moving through its long seasons. For humanity, Mars has always symbolized possibility. It is the most Earth-like of the other planets, close enough that spacecraft can reach it, and with conditions that, while harsh, are not impossible. Probes and rovers have been exploring Mars for decades, sending back images of rocky plains, hills, and skies tinted pink by dust. The rovers move slowly, their wheels pressing into the soil, their cameras turning toward distant horizons. They are patient explorers, revealing Mars not in dramatic discoveries, but in steady observations. A rock layered by ancient water, a mineral that formed in the presence of moisture, a horizon softened by dust. Each detail adds to a story of a planet that once held more, and that now waits in stillness. Mars has been the subject of dreams of human exploration. People imagine walking on its surface, building shelters, perhaps even creating a new home there. Yet beyond these visions lies the reality that Mars is, at its core, a quiet frontier. It does not rush to reveal its secrets. It does not call loudly. It waits, patient and distant, offering its surface to those who come with curiosity. In this way, Mars teaches us something about perspective. Frontiers do not need to be conquered or claimed. They can simply be places of reflection, showing us the diversity of worlds and the patience of time. Culturally, Mars has inspired stories for centuries. It has been seen as a symbol of energy, of fire, of struggle. But when we see the actual images from its surface, the pale skies, the dusty plains, the quiet rocks stretching into the horizon, a different image emerges, not one of conflict, but one of calm. Mars is not a place of storms and fire, but of silence, where the loudest voice is the wind moving dust across stone. To reflect on this is to let go of old associations and to see Mars as it is, not a planet of war, but a frontier of stillness. To imagine standing on Mars is to imagine a horizon that feels both familiar and alien. Mountains rise in the distance. Dust softens the light, and above, Earth is a pale dot in the sky. This view, though unreachable for most of us, offers perspective. It shows that Earth itself is small, part of a larger family of planets. It reminds us that home is rare and that the universe is vast. And it invites us to rest in the awareness that exploration is not always about movement outward, but also about reflection inward. As you picture Mars, you may allow yourself to feel its patience. A planet smaller than Earth, colder, quieter, and yet rich in history. A world that once held water and now holds silence, that continues its orbit as it has for billions of years. Mars is a frontier, but not one that demands. It simply is, steady and waiting, a reminder that in stillness there can be depth. And so, as your breath moves gently in and out, you may think of Mars circling the sun, glowing red in the night sky. It is a quiet companion beyond Earth, neither loud nor demanding, simply present. Its silence can mirror your own, offering space for calm, for rest, for peace. In the quiet frontier of Mars, you may find the same quiet within yourself. Between Mars and Jupiter lies a wide region of space known as the Asteroid Belt. From a distance, it may sound like a dense barricade of rocks, a crowded realm that spacecraft must navigate carefully. In truth, the asteroid belt is not chaotic or impenetrable. It is a quiet zone where countless rocky bodies move slowly in orbit, separated by vast spaces of emptiness. The belt is not a wall, but a gentle divide, marking the transition between the smaller, rocky worlds of the inner solar system and the immense gaseous giants beyond. To reflect on the asteroid belt is to reflect on boundaries that are not barriers, but spaces of quiet separation and balance. The asteroids themselves are remnants from the early solar system, pieces of rock and metal that never came together to form a planet. More than 4 billion years ago, when the planets were still forming from a disk of gas and dust, this region might have become another world. But Jupiter, with its immense gravity, disturbed the process. Its pull kept material from combining fully, leaving behind fragments, small bodies orbiting the sun, each following its own path. In this way, the asteroid belt is a kind of museum, preserving the building blocks of planets in their simplest forms. To look at it is to look backward in time into the quiet beginnings of the solar system. Though we call it a belt, the region is vast. It stretches hundreds of millions of kilometers across space, circling the sun in the same plane as the planets. Within this space, there are millions of asteroids, but they are spread so far apart that traveling through the belt would not feel crowded. A spacecraft moving across it would pass mostly through emptiness, occasionally glimpsing a rocky body. In the distance, the belt is more like a thin veil than a dense barrier, a reminder that even when we imagine congestion, space is often filled with silence and distance. The asteroids vary widely in size. Some are tiny, little more than pebbles drifting in space. Others are immense, hundreds of kilometers across. The largest, Ceres, is so big that it is classified as a dwarf planet, with enough gravity to shape itself into a nearly spherical form. Other large bodies include Vesta, Pallas, and Hygiea, each unique in composition and history. Together, these larger asteroids anchor the belt, while countless smaller fragments orbit alongside them. To imagine them all is to imagine diversity. In quiet motion, a community of worlds too small to dominate, yet too enduring to vanish. The surfaces of asteroids are rocky and ancient, covered in craters from billions of years of collisions. Some are rich in metal, remnants of cores from bodies that never fully formed. Others are carbon-rich, holding clues about the chemistry that may have influenced life's beginnings on Earth. Scientists study asteroids, not only for their history, but also for what they may reveal about ourselves. They are time capsules, untouched by atmosphere or weather, preserving the raw materials from which planets like Earth were made. In their silence, they carry knowledge. The asteroid belt also plays a protective role. Jupiter's gravity helps deflect many wandering comets and asteroids, reducing the number that might strike the inner planets. Still, some fragments do cross Earth's path, reminding us that we are not separate from this wider system. The craters. On Earth, the scars of ancient impacts are reminders of these connections. But most asteroids remain in their quiet orbits, circling the sun patiently, never straying far from their region. Their presence is not a threat, but a background rhythm. In the solar system's larger harmony dot, to imagine the asteroid belt is to imagine stillness broken by occasional encounters. Collisions do happen, slowly reshaping the distribution of bodies. When they occur, fragments scatter, some drifting into new orbits. Yet even these events are part of a larger balance. Over billions of years, the belt has remained, not dissolved, into chaos, not transformed into a planet, but continuing in its quiet divide between worlds. This persistence can be reassuring. It shows us that not all processes lead to completion. Some remain unfinished, and in their unfinished state, they find stability. Spacecraft have visited the belt, offering us glimpses of its worlds. NASA's Dawn mission traveled to Vesta and Ceres, orbiting and studying them in detail. The images revealed landscapes of craters, mountains, and bright spots, features shaped by impacts and chemistry. These missions showed us that even small bodies can hold surprises. Ice beneath the surface, signs of past activity, or minerals that formed in unexpected ways. To explore an asteroid is to explore a world that is both simple and complex, small in size, but rich in history, not in human imagination. The asteroid belt has sometimes been seen as a frontier for exploration, perhaps even for resources. Metals and minerals within asteroids, could one day be used to support life beyond Earth. But beyond practical visions, the belt already offers something profound, a reminder of time and patience. These bodies have circled the sun for billions of years, neither forming into something larger nor dispersing entirely. They are fragments, but they are also survivors. Their endurance mirrors the endurance of cycles, the persistence of matter. In motion, the calm of paths that repeat endlessly. Culturally, we may think of boundaries as barriers, lines that divide one space from another. The asteroid belt challenges this idea. It is a boundary, yes, but a gentle one. It does not block the way between Mars and Jupiter. It does not prevent passage. Instead, it marks a transition, a space between regions of the solar system. Inner planets are small, rocky, and dense. Beyond the belt, the giants begin: Jupiter, Saturn, Uranus, Neptune. The belt is a pause between these worlds, a region of fragments before the vastness of gas. It is less a wall than a threshold, quiet and subtle, but significant dot as you picture the asteroid belt. You may imagine countless small bodies, each on its path, circling the sun in patient harmony. Between them stretches silence, vast distances where nothing interrupts the emptiness. It is not a chaotic crowd, but a slow dance of fragments, each moving at its own pace, each balanced by the sun's gravity. To rest with this image is to rest with the idea that boundaries can be soft, that divisions can be gentle, that transition can carry its own calm. And so, as your breath moves steadily in and out, You may think of the asteroid belt circling quietly, a veil between worlds. It holds the memory of beginnings, the fragments of creation, the patience of billions of years. It does not need to become something more. It is enough as it is, a gentle divide, steady, silent, and enduring. In this recognition, you may find peace, knowing that not every journey must end in completion, and that even in fragments, there can be harmony. Jupiter is the largest planet in our solar system, a world so immense that it could contain more than 1,000 Earths within its volume. When we think of Jupiter, we are not thinking of a rocky world like Earth or Mars, but of a giant sphere of gas, swirling with clouds and storms. It does not have a solid surface as we know it. Instead, it is an ocean of hydrogen and helium, becoming denser as you move inward, eventually leading to a deep, hidden core. Jupiter's vastness makes it unique, but it is not only size that gives it importance. Jupiter serves as a guardian, its immense gravity shaping the solar system, protecting the inner planets, and reminding us that strength can take the form of quiet stability, orbiting the Sun at a distance of about 5 times that of Earth. Jupiter completes one revolution every 12 years. Its slow, steady path reflects its mass and gravity. Where small bodies might be deflected or drawn into chaos, Jupiter remains unshaken, circling with calm persistence. To picture Jupiter in its orbit is to picture an anchor in space, balancing the dance of smaller bodies, guiding comets, asteroids, and fragments with its gravitational reach. The most familiar feature of Jupiter is its atmosphere, a canvas of swirling clouds arranged in bands of white, orange, and brown. These bands stretch around the entire planet, created by strong winds, moving in opposite directions at different latitudes. From afar, they look like soft stripes, painted in flowing patterns that never quite repeat. Within this atmosphere lies the Great Red Spot, a storm larger than Earth, which has been raging for centuries. Despite its size and power, the storm rotates with graceful slowness, turning in calm cycles that last for days. To observe the Great Red Spot is not to see violence, but endurance. It is a reminder that even in turbulence, there can be continuity. And Jupiter radiates more energy than it receives from the Sun due to the slow contraction of its massive body. This process generates heat, driving its winds and storms. Yet for all this energy, Jupiter does not threaten. It does not send fire outward. Instead, it absorbs, deflects, and stabilizes. Its gravity captures wandering comets and asteroids, reducing the number that might collide with Earth or other inner planets. Without Jupiter, the inner solar system might be far more chaotic, filled with impacts. In this way, Jupiter plays the role of protector, a quiet guardian whose size and strength create safety. To reflect on this role can bring calm. In the vastness, there are forces that shield as well as forces that challenge. Jupiter is not alone. Surrounding it are dozens of moons. More than 90 have been discovered, forming a miniature solar system of their own. The 4 largest, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. Each is unique, each a world in its own right. Isu is volcanic, with lava fountains and a surface reshaped constantly. Europa is icy, with a smooth shell that may conceal an ocean beneath, a place where life could possibly exist. Ganymede is the largest moon in the solar system, even bigger than Mercury, with its own magnetic field. Callisto is ancient and cratered, a record of billions of years. To imagine these moons circling Jupiter is to imagine a family of worlds, each with its own character, bound together by gravity in a graceful endless dance. The magnetosphere of Jupiter is immense, the largest structure in the solar system after the sun's influence itself. It stretches millions of kilometers into space, enveloping its moons and capturing charged particles. This field creates powerful radiation belts, invisible to the eye, yet essential to understanding the environment of the planet. Though harsh for spacecraft, the magnetosphere is another expression of Jupiter's reach. Its influence extends far beyond its visible body, shaping space itself in quiet, unseen ways. Culturally, Jupiter has always symbolized greatness and protection. In Roman mythology, Jupiter was the king of the gods, ruling with authority. In astronomy, the planet has held a similar role, its size and prominence making it an unmistakable presence. To look at Jupiter through a telescope is to see more than just a planet. It is to see movement and pattern, to glimpse storms and bands that are alive with rhythm. And yet, from Earth's surface, Jupiter appears simply as a bright point of light, steady and reassuring. Its calm presence in the night sky reflects its role in the solar system. Large, enduring, and protective, exploration has deepened our understanding of Jupiter. The Pioneer and Voyager spacecraft first flew past in the 1970s, revealing its storms and moons. Later, the Galileo mission orbited Jupiter for years, sending back detailed images of its atmosphere and satellites. Today, NASA's Juno mission continues to study the planet, diving close to its clouds, measuring its magnetic field, and revealing new details about its structure. These missions have shown us that Jupiter, though immense, is not distant from our understanding. It is a world we can know, one that continues to reveal itself with patience. In human imagination, Jupiter represents strength. But in its actual nature, it also represents gentleness. It is vast, yes, and powerful, but it uses that power to hold the solar system in balance. It teaches us that size need not be overwhelming, that greatness can serve stability rather than chaos. To reflect on Jupiter is to reflect on guardianship, not a loud or forceful presence, but a steady one, guiding and protecting by simply being what it is. As you picture Jupiter, you may allow yourself to see its softly banded clouds, its patient orbit, its family of moons circling in harmony. You may imagine the great red spot turning slowly, as it has for centuries, a storm that endures not with violence, but with calm persistence. You may think of its gravity deflecting comets, shaping orbits, protecting inner worlds. And in this image, you may feel reassured. The solar system is vast, and yet within it, there are structures of care. Jupiter's presence reminds us that not all immensity is threatening. Some immensity protects, steadies, and sustains. As your breath moves in gentle rhythm, like the turning of clouds on Jupiter, you may rest in the awareness of guardianship, the sense that even in the vastness, there are forces that hold, balance, and shield. Jupiter, the giant of the solar system, is not only a planet of grandeur, but also a planet of calm protection. And in that reflection, there is peace. Among all the planets of the solar system, Saturn is perhaps the most instantly recognizable. Its wide, gleaming rings encircle the planet like a delicate ornament, a structure so striking that even the smallest telescope reveals its beauty. To think of Saturn is to think of elegance, of harmony, of balance expressed in celestial form. It is not the largest planet. Jupiter holds that title, but Saturn is, in many ways, the most graceful. Its rings, its pale golden hue, and its family of moons create a vision of cosmic order. To reflect on Saturn is to reflect on beauty that is vast, patient, and enduring. Saturn is a gas giant, like Jupiter, composed mostly of hydrogen and helium. It is less dense than water, meaning that if there were a cosmic ocean large enough, Saturn would float. This lightness contrasts with its immensity, more than 9 times wider than Earth, with a mass 95 times greater. And yet, for all its size, Saturn appears gentle. Its soft yellow and gold bands, created by subtle variations in its atmosphere, give it a calm presence. Unlike the stormy look of Jupiter, Saturn seems smoother, quieter, as if wrapped in calm. The rings of Saturn are its defining feature. Composed of countless particles of ice and rock, ranging from grains of dust to boulders meters wide, they form a structure both delicate and immense, stretching more than 280,000 kilometers across, yet only a few tens of meters thick. The rings are like a veil, wide but fragile. They orbit the planet in harmony, divided into distinct bands, each held in place by Saturn's gravity and by the influence of its moons. To look at the rings is to see order within complexity, a structure that endures through balance. The rings appear solid from afar. They are not. They are billions of tiny fragments, each moving in its own orbit, each circling Saturn like dancers in a vast, silent ballet. Sunlight reflects off their icy surfaces, making them gleam with brightness. Sometimes shadows fall across them, cast by the planet itself or by moons passing nearby, creating patterns of light and shade. The rings are not permanent. They slowly change, and over millions of years, they may fade. But for now, and for many future generations, they remain one of the most breathtaking sights in the solar system. Saturn also hosts a remarkable family of moons, more than 80 known so far. Among them are worlds as fascinating as entire planets. Titan, the largest, is bigger than the planet Mercury. Wrapped in a thick atmosphere of nitrogen, it has rivers, lakes, and seas, not of water, but of liquid methane and ethane. Beneath its icy crust may lie a hidden ocean of water, raising the possibility that Titan, though alien, could support some form of life. Enceladus, a smaller moon, also holds wonders. Beneath its frozen surface lies a global ocean and geysers of water. Vapor erupt from cracks, spraying into space. These plumes contain organic molecules, hinting at chemistry that might support life. To imagine Enceladus is to imagine a world hidden beneath ice, quiet and distant, yet alive with possibilities. Other moons add to Saturn's harmony. Mimas, with its large crater, resembles a cosmic eye. Iapetus has one hemisphere brighter than snow, and the other darker than coal. Rhea, Dione, and Tethys circle gracefully, each contributing to the balance of Saturn's system. Some moons, called shepherd moons, play a role in shaping the rings, their gravity guiding the particles and keeping them in place. In this way, Saturn's moons and rings are not separate, but part of a single structure, each influencing the other in a quiet dance of gravity and motion. The atmosphere of Saturn is gentle in appearance, but it holds storms and winds that are among the fastest in the solar system, reaching speeds of over 1,000 kilometers per hour. One of its most mysterious features is a storm at the North Pole, shaped like a perfect hexagon, a six-sided pattern created by atmospheric flows. This geometric storm, vast enough to hold Earth within it, has persisted for decades. Yet, despite its scale, it rotates slowly, almost hypnotically, like a pattern repeating in silence. To imagine the hexagon is to imagine order in turbulence, shape within motion, harmony within energy. Culturally, Saturn has long been associated with time, cycles, and order. In Roman mythology, Saturn was linked to agriculture and the passage of seasons. The planet's slow orbit, nearly 30 Earth years for one circuit of the Sun, reflects this association with patience and long cycles. Saturn is not a planet of haste. It moves deliberately, marking decades as it completes its path. Its rhythm is measured, slow, and enduring, mirroring the patience of time itself. Exploration of Saturn has revealed much about its beauty. Pioneer and Voyager missions first showed us the rings in detail, transforming points of light into intricate structures. Later, the Cassini mission orbited Saturn for over a decade, sending back countless images of its clouds, rings, and moons. Cassini flew through the plumes of Enceladus, revealing their secrets, and parachuted the Huygens probe down to Titan's surface, showing us landscapes shaped by liquid lakes and rivers. When Cassini's mission ended, it was sent into Saturn's atmosphere, burning brightly as it descended, a final gesture of exploration. The knowledge it left behind continues to shape our understanding of Saturn's system as one of the most complex and beautiful in the solar system. Saturn reminds us that beauty in the universe can be immense yet delicate. Its rings are grand, but made of small, fragile pieces. Its moons are diverse, each with its own character, yet all bound together by gravity. Its atmosphere appears calm, yet holds deep patterns and storms. To reflect on Saturn is to reflect on harmony and contrasts, strength and fragility, immensity and delicacy, calmness and motion. As you picture Saturn, you may imagine its pale, golden sphere encircled by glowing rings, wide and bright against the blackness of space. You may imagine Titan with its hazy atmosphere, Enceladus with its icy plumes, and countless smaller moons tracing paths across the sky. You may see the rings shimmering, each particle in its own orbit, yet all together forming something beautiful. And as you breathe gently, in and out, you may feel that same sense of balance within yourself. Countless small moments, each part of a larger harmony, each forming the ring of your own experience. Saturn is the planet of rings, but more than that, it is the planet of balance. It shows us that beauty can be built from countless small pieces. It shows us that harmony can exist in motion. It shows us that patience, slowness, and rhythm can create something lasting. To rest with Saturn is to rest with grace, with order, and with peace. Among the outer giants of the solar system, Uranus holds a quiet mystery. From a distance, it appears as a pale blue-green sphere, softly glowing against the dark. Unlike Jupiter with its bands of storms or Saturn with its grand rings, Uranus seems simple at first glance. Yet simplicity hides uniqueness. Uranus is tilted so far on its axis that it essentially rolls around the Sun on its side. This tilt makes Uranus unlike any other planet, shaping its seasons, its appearance, and its story. To reflect on Uranus is to reflect on difference, on unusual rhythms, and on the calm beauty of uniqueness. Uranus is the seventh planet from the Sun, orbiting at nearly 20 times Earth's distance. It takes 84 Earth years to complete one revolution, which means that a single Uranian year lasts almost a human lifetime. Because of its tilt of 98 degrees, Uranus does not rotate upright like most planets. Instead, it leans, so far over that its poles point nearly toward the Sun. As it circles, one hemisphere is bathed in sunlight for decades, while the other rests in long, cold darkness. When the seasons finally shift, the process reverses, bringing light to the other side. These extreme seasons unfold slowly, not in weeks or months, but in spans of decades. To imagine this is to imagine patience on a planetary scale, a rhythm so slow that it exceeds human experience. The tilt of Uranus is likely the result of a great collision in the distant past, when a large body struck the planet and knocked it onto its side. Though the event itself is long gone, the result remains, a world permanently tilted, forever different. Yet in this difference lies stability. Uranus has continued in this posture for billions of years, circling the sun calmly, steady in its unique rhythm. To reflect on this can feel reassuring. Even after great upheaval, balance can emerge, and what seems unusual can endure with quiet grace. The atmosphere of Uranus gives the planet its distinctive color. Composed mainly of hydrogen and helium, with a small amount of methane, it absorbs red light and reflects blue-green. From afar, the planet appears serene, as though covered in a soft, pale veil. Unlike the stormy patterns of Jupiter or the glowing rings of Saturn, Uranus shows little detail to the naked eye. It appears smooth, calm, almost featureless. Yet beneath this calmness lie winds and storms, moving with speeds of hundreds of kilometers per hour. These winds do not break the planet's serenity from a distance, but they remind us that stillness can contain movement, that calm surfaces often hide quiet energy within. Uranus also has rings, though they are faint compared to Saturn's. Dark and narrow, they were discovered only in the late 20th century. They circle the tilted planet in alignment with its unusual axis, creating a geometry unlike any other. When viewed edge-on, the rings nearly disappear, thin as threads of shadow. When viewed from above, they appear as concentric circles, delicate and understated. These rings, though less dramatic than Saturn's, add to Uranus's character, subtle rather than grand, reminding us that beauty can be quiet and reserved. The moons of Uranus add to its uniqueness. More than 24 are known, many named, after characters from the plays of Shakespeare and the poems of Alexander Pope. Among them are Titania, Oberon, Ariel, and Miranda, each with its own landscape of valleys, ridges, and cliffs. Miranda, in particular, holds strange features, canyons and surfaces that seem pieced together, as if reshaped by ancient upheaval. These moons are not as large or as famous as Jupiter's or Saturn's, but they carry their own stories, circling their tilted parent with patience. To picture them is to picture companions in orbit, keeping time with Uranus's unusual rhythm. Exploration of Uranus has been limited. Only one spacecraft, Voyager 2, has flown past. In 1986, it revealed a smooth, blue-green world with faint rings and moons, and it confirmed the extreme tilt of the planet. Since then, Uranus has been observed from Earth and from telescopes in space, but it has not been visited again. This distance and mystery give Uranus a quiet presence in our imagination. It does not call for attention, but waits patiently, rolling along its path, steady in its silence. One day, missions will return to study it more closely, but for now, Uranus remains a distant neighbor, serene and unhurried. The cold of Uranus is another of its defining qualities. It is among the coldest planets in the solar system, with temperatures dropping below -200 degrees Celsius. This chill comes not only from its distance from the sun, but also from its lack of internal heat. Unlike Jupiter and Saturn, which radiate more heat than they receive, Uranus seems quiet within, emitting little extra energy. It is as if the planet has settled into stillness, radiating only what it must, conserving its calm. To reflect on, this is to sense rest, a planet that does not burn brightly, but endures softly in the cold dot culturally. Uranus is often less celebrated than its brighter neighbors. It is faint, just at the edge of visibility to the naked eye, often overlooked among the stars. Yet its presence has significance. Its discovery in 1781 expanded the known solar system, showing humanity that the universe was larger than we thought. Uranus was the first planet found with a telescope, a reminder that knowledge comes not only from what we see directly, but from what we patiently observe. Its quiet glow in the night sky is not obvious, but it is there, steady and real dot to reflect. On Uranus is to reflect on uniqueness. A planet tilted on its side, moving in long seasons, faint in the sky yet vast in reality. Its differences do not diminish it, they define it. Uranus teaches that being unusual is not a flaw, but a form of beauty. Its tilt creates rhythms unlike any other. Its faint rings and subtle moons add to its quiet character. Its coldness and distance remind us that calm can exist even at the edges of the sun's warmth. As you picture Uranus, you may imagine a pale blue sphere, serene and tilted, rolling gently along its orbit. You may see faint rings encircling it, moons circling in patient paths, seasons shifting slowly over decades. You may sense its calmness, its quiet endurance, its soft glow against the black sky. And as you breathe gently, you may rest in the end. Awareness that difference can be beautiful, that calm can be enduring, and that even in tilt, there can be balance. Uranus is the tilted world, unique in posture, subtle in presence, steady in rhythm. It shows us that harmony does not always look the same, that balance can take unexpected forms. To rest with Uranus is to rest with the comfort of uniqueness, the patience of long cycles, and the peace of quiet endurance. At the far edge of the planetary system lies Neptune, a world so distant that it completes only one orbit of the Sun in 165 Earth years. It is a planet that in many ways embodies mystery. To the naked eye, it cannot be seen. Its discovery came, not from direct sight, but from mathematics. The subtle tug of its gravity on Uranus betrayed its presence. In 1846, astronomers looked where the numbers pointed, and there Neptune was, a pale, distant sphere, circling patiently at the frontier of our solar system. To reflect on Neptune is to reflect on distance, on patience, and on the quiet beauty of what lies at the edge. Neptune is a giant planet, similar to Uranus in size and composition, but distinct in color and character. Its atmosphere contains hydrogen, helium, and methane, but the balance of elements gives it a deeper, more vivid blue than Uranus. When sunlight touches Neptune, much of the red light is absorbed, and what reflects back is a rich, calming blue, the color of deep seas and distant skies. To imagine Neptune glowing against the black of space is to imagine serenity itself, a soft lantern shining from far away, a dreamlike presence at the solar system's boundary. The winds of Neptune are among the fastest in the solar system, reaching speeds of over 2,000 kilometers per hour. These winds circle the planet in wide bands, driving storms that appear as dark spots on its surface. The Great Dark Spot, first observed by the Voyager 2 spacecraft, was a storm the size of Earth, rotating calmly in Neptune's upper atmosphere. Unlike Jupiter's long-lasting red spot, Neptune's storms appear and fade within years, changing with the planet's weather. These storms may sound fierce, but in Neptune's vastness, they move with rhythm, part of the planet's quiet balance of energy. To think of these winds is not to think of violence, but of endurance, a reminder that even in distance, motion continues, steady and constant. Neptune's orbit places it more than 30 times farther from the Sun than Earth. At such a distance, sunlight is faint, nearly 1,000 times weaker than what we experience on Earth. Days on Neptune are dim, like perpetual twilight. And yet, even in this dimness, the planet shines. Its clouds reflect the light they receive, and its deep blue atmosphere glows softly. This resilience to glow even when light is scarce is one of Neptune's quiet lessons. It shows that presence does not require brilliance, and that beauty can exist even on the margins. The interior of Neptune holds mysteries as well. Beneath its atmosphere lies a mantle of water, ammonia, and methane ices, swirling under immense pressure. Deeper still, there may be a rocky core, hidden and unreachable. Some scientists believe that within Neptune's mantle, diamonds may form, created by pressure that forces carbon into crystals. Whether or not these diamonds exist, the idea itself speaks of transformation, of hidden beauty forged in silence. Far from sight. Neptune is not alone. It has a system of faint rings, narrow and dark, discovered in the late 20th century. These rings are not as bright as Saturn's, but they form subtle arcs, held in place by small moons that act as shepherds. The presence of rings at Neptune is another reminder that beauty is not limited to what is obvious. Even the faintest structures, nearly invisible, add to the harmony of the planet. Neptune also hosts 14 known moons, the largest of which is Triton. Triton is unique among moons. It orbits Neptune in the opposite direction of the planet's rotation, a retrograde path that suggests it was captured long ago from the Kuiper Belt. Triton is geologically active, with geysers of nitrogen gas erupting from beneath its icy surface. Beneath that ice, there may be a hidden ocean, warmed by tidal forces. Triton is not just a satellite, but a world of its own. A reminder that even at the edge of the solar system, there may be surprises waiting. Culturally, Neptune carries the name of the Roman god of the sea, fitting for a planet so blue and so fluid in character. Its deep color, its swirling winds, and its hidden depths mirror the imagery of oceans. To think of Neptune is to think of distance and depth, of waters unexplored, of mysteries that are more felt than seen. It is the dream of a sea at the edge of the solar system, calm and vast, endless and silent. Our exploration of Neptune has been brief. Only one spacecraft, Voyager 2, has flown past. In 1989, it revealed the planet's atmosphere, its storms, its rings, and its moons, sending back images that remain our most detailed views. Since then, Neptune has been studied from afar by telescopes, but no mission has returned. This distance, combined with its faintness, gives Neptune an air of secrecy. It waits quietly, circling the sun, largely unseen. Its patience reflects the patience of the cosmos itself, moving in rhythms too long for human lifetimes to measure. Directly. To reflect on Neptune is to reflect on the edge of familiarity. It is the last of the known giant planets, the outermost guardian of the solar system's architecture. Beyond it lie the icy bodies of the Kuiper Belt and the distant Oort Cloud, but Neptune marks the end of the classical planets, the boundary of what was known for centuries. In this way, Neptune is both a planet and a threshold, a reminder that every edge is also a beginning, every frontier a gateway to something beyond. As you picture Neptune, you may imagine its deep blue glow, softly lit by distant sunlight. You may see faint rings encircling it, and Triton circling in its unusual path. You may feel the quiet of distance, the patience of centuries, the calm of a planet that moves slowly in its long orbit, unhurried and serene. And as your breath moves gently in and out, like the slow winds circling Neptune's atmosphere, you may rest in the awareness that even at the edges, there is beauty. Neptune is the distant dream, a planet far from the warmth of the sun, yet glowing with its own calm radiance. It teaches that distance does not erase presence, that faintness does not erase beauty, and that patience itself can be a form of strength. To rest with Neptune is to rest with the idea of horizons, that beyond what we see, there are always new spaces, waiting quietly, glowing softly, dreaming in the dark. Beyond the familiar 8 planets lies a quieter family of worlds, the dwarf planets. They are not as large as Jupiter or Saturn, not as bright as Venus, not as close as Mercury or Mars. They are smaller, more distant, more subtle. Yet their presence adds depth to our understanding of the solar system. They are silent travelers, moving patiently in their orbits, carrying stories of beginnings and reminders that significance does not always depend on size. To reflect on the dwarf planets is to reflect on humility, on diversity, and on the quiet beauty of worlds that exist on the edges. The best known of the dwarf planets is Pluto. For much of the 20th century, Pluto was called the 9th planet, discovered in 1930 by Clyde Tombaugh. For generations, children learned the names of 9 planets, ending with Pluto. But in 2006, astronomers redefined what it means to be a planet, and Pluto's classification changed. It became the first of a new category, dwarf planet. This change did not diminish Pluto's importance. It only placed it within a broader understanding of the solar system, alongside other bodies of similar size. To think of Pluto is to think of change in perspective, of learning to see not less, but more. Pluto orbits the Sun in a long, stretched path, taking 248 Earth years to complete one circuit. Its orbit is tilted compared to the other planets, carrying it sometimes above and sometimes below the plane of the solar system. This unusual path reflects its independence, its willingness to move differently. Pluto also travels with a companion, its largest moon, Charon. Charon is so large compared to Pluto that together they form a kind of double world, orbiting a point between them. To imagine Pluto and Charon circling each other is to imagine companionship in the farthest cold, 2 worlds bound together, moving in harmony through the distant dark. The surface of Pluto is varied, with plains of nitrogen ice, mountains of water ice, and even glaciers that move slowly across the landscape. The New Horizons spacecraft, which flew past Pluto in 2015, revealed a heart-shaped plain, a feature that captured imaginations. To see such a symbol on a distant world felt meaningful, as though Pluto itself was quietly reminding us that even at the farthest reaches, beauty can be soft and inviting. The photographs showed a world not barren, but dynamic, with signs of activity beneath its frozen surface. Pluto may be small, but it is alive with quiet complexity. Beyond Pluto lies Ceres, another dwarf planet, slightly smaller but more massive. Discovered in 2005, Ceres was one of the reasons astronomers reconsidered the definition of planet. Its presence showed that Pluto was not unique, that many such bodies existed in the Kuiper Belt, the region of icy objects beyond Neptune. Ceres orbits even farther out, taking more than 500 years to circle the Sun. It is distant, cold, and faint, yet its gravity and motion remind us that the solar system extends far beyond what we see easily. Ceres is a quiet traveler, patient and steady, embodying the endurance of distance. Haumea is another member of this family, distinctive for its unusual shape. Unlike the nearly spherical planets, Haumea is elongated, stretched into an oval by its rapid rotation. It spins on its axis in less than 4 hours, making it one of the fastest rotating bodies in the solar system. This speed shapes its form, making it appear as though it has been gently pulled at the sides. Haumea is also accompanied by rings and moons, adding to its uniqueness. To reflect on Haumea is to reflect on difference, on how rhythm and motion shape identity. Makemake, discovered in 2005, is another dwarf planet of the Kuiper Belt. It is smaller than Pluto, but still large enough to hold its round shape. Its name comes from the mythology of Easter Island, reflecting humanity's practice of linking distant worlds with cultural stories. Makemake is bright compared to many other distant objects, its icy surface reflecting sunlight faintly across. Space. It reminds us that even in distance, worlds can shine, not brilliantly, but softly, like distant lanterns glowing in the dark. Closer to home lies Ceres, the only dwarf planet in the inner solar system. Located in the asteroid belt between Mars and Jupiter, Ceres is the largest object in that region. For a time in the 19th century, it was even called a planet. Today, we know it as a dwarf planet, a reminder that categories change as knowledge grows. Ceres is small, yet it holds water ice beneath its surface, and bright spots of salt were discovered by the Dawn spacecraft in 2015. These spots glowed like eyes against the darker surface, surprising and mysterious. Ceres shows us that even in familiar regions, there are worlds with secrets, waiting quietly to be understood. Together, these dwarf planets remind us that the solar system is not simple. It is not only 8 planets circling the Sun, but a family of diverse bodies, large and small, near and far, bright and faint. The dwarf planets are not less important because of their size. They are teachers of perspective, showing that value is not always tied to scale. Each carries history. Each holds evidence of the solar system's early days. Each moves in rhythm with the Sun, circling patiently, enduring through billions of years. Culturally, dwarf planets also carry lessons. The reclassification of Pluto sparked emotions, sadness, nostalgia, resistance. People felt attached to Pluto as the 9th planet. Yet over time, many came to see that the change expanded, rather than reduced, our understanding. The solar system is more complex, more diverse, more beautiful than a simple list of 9. To accept Pluto as a dwarf planet is to accept growth in knowledge, to welcome complexity, and to rest in the idea that definitions may shift, but beauty remains. To imagine the dwarf planets is to imagine small spheres, glowing faintly, moving slowly at the edges of sunlight. They do not demand attention. They do not dominate the night sky. They travel quietly, patient in their orbits, content in their roles as silent companions of the larger worlds. To reflect on them is to reflect on humility, on presence without grandeur, on endurance without noise. As you picture these dwarf planets, Pluto with its heart, Eris in its distance, Haumea spinning, Makemake shining faintly, Ceres glowing with salt, you may allow yourself to feel their quietness. They are not loud or dramatic, but steady, enduring, present. They remind us that not everything needs to be large to be meaningful, that not everything needs to shine brightly to be seen. In their silence, they offer peace. And so, as your breath continues in its gentle rhythm, you may imagine the dwarf planets circling the Sun, silent travelers at the edges and in the spaces between. They are small, yes, but they are part of the whole, part of the harmony, part of the family of worlds. Their journeys are long, their voices soft, their presence enduring. To rest with them is to rest with patience, with humility, and with calm. Comets are among the most poetic travelers of the solar system. For most of their long orbits, they remain hidden, silent bodies of ice and dust moving far from the Sun in the outer darkness. Then, from time to time, one draws inward, and as it approaches the Sun, it transforms. The heat releases gas and dust, creating a glowing coma and a sweeping tail that stretches across the sky. To see a comet is to see movement made visible, a messenger of ice and light crossing the heavens. To reflect on comets is to reflect on cycles of return, on journeys of patience, and on the beauty of transformation. A comet is often called a dirty snowball, a mixture of frozen water, carbon dioxide, ammonia, methane, and dust. Its core or nucleus is usually only a few kilometers across. Small, dark, and solid, it moves quietly through space, unnoticed until sunlight awakens it. When a comet nears the sun, the warmth causes its ices to sublimate, turning directly into gas. This gas, along with entrained dust, forms a glowing atmosphere around the nucleus called the coma. From this coma, the solar wind pushes material outward, creating the tails that give comets their distinctive appearance. One tail is made of dust, curved and golden. The other is made of gas, straight and pale blue, always pointing directly away from the sun. These tails can stretch for millions of kilometers, yet the nucleus that creates them remains tiny. This contrast, small body, vast display, reminds us that even the smallest things can create great beauty when illuminated. The orbits of comets vary widely. Some return every few years, like Comet Encke, circling the sun in a short cycle. Others take centuries or millennia to return, spending most of their time in the distant reaches of the solar system. The most famous, Halley's Comet, appears about once every 76 years. It has been recorded by human observers for thousands of years, inspiring awe in many cultures. To know that a comet returns after such a long span is to know that patience is part of the cosmos. A single lifetime may see one comet only once, yet the comet continues, repeating its orbit without haste, without end. Far beyond the planets lies the Oort Cloud, a vast, spherical shell of icy bodies that may extend halfway to the nearest stars. Many long-period comets are thought to come from this region. They drift in silence for billions of years, disturbed only occasionally by passing stars or galactic tides, which send them inward. From this perspective, a comet we see in the night sky has traveled an immense distance, perhaps for millions of years, before gracing us with its glow. To reflect on this is to reflect on perspective. What feels fleeting to us may be the continuation of an ancient journey. The surfaces of cometary nuclei are dark, often blacker than coal, covered in organic compounds. This darkness contrasts with the brilliance of their tails. The same body that appears faint and unnoticed in space becomes radiant when touched by sunlight. Some scientists believe that comets may have carried water and organic molecules too, the early Earth seeding the building blocks of life. If so, comets are not only messengers of beauty, but also messengers of origin, carrying ingredients that helped make our world habitable. Even if this role is still debated, the idea that life on Earth is connected to distant icy travelers offers a sense of kinship with the cosmos. Comets have often inspired wonder and fear in human cultures. Before their nature was understood, their sudden appearance in the sky was seen as an omen of change, of fate, of events to come. Yet in truth, comets are natural members of the solar system, moving in cycles as steady as the planets. Their unpredictability from a human perspective is simply the result of their long orbits. To know this is to release fear and to see comets as part of the same harmony that shapes all celestial bodies. They are not warnings, but reminders of the depth of time and the continuity of cycles. Modern exploration has revealed comets more closely. In 2014, the European Space Agency's Rosetta mission became the first spacecraft to orbit a comet, 67P, Churyumov-Gerasimenko. It even sent a small lander, Philae, which touched down on the comet's surface. Images showed cliffs, boulders, and jets of gas erupting into space. These discoveries transformed comets from distant lights into worlds with landscapes, activity, and character. They are not just streaks in the sky, but small, ancient bodies with stories etched into their surfaces. The life of a comet can be seen as a cycle of quiet and brilliance. For most of its orbit, it is quiet, frozen, unseen in the dark. Then, for a brief time near the sun, it shines, trailing light across the sky before fading again into distance. This rhythm is not unlike breathing, expansion and contraction, presence and absence, always returning, always continuing. To reflect on this rhythm is to find calm. It shows us that brightness is not constant, but cyclical, and that rest is. As important as display. Comets remind us that beauty does not need permanence. A comet's tail may last only weeks, then vanish. Yet the memory of its presence remains, inspiring those who saw it, connecting them to a cosmic cycle that will continue long after. In this way, comets embody impermanence as grace, reminding use that fleeting moments can carry meaning, and that transience itself can be peaceful. As you picture a comet, you may imagine a tiny nucleus of ice and dust, dark and quiet, moving slowly through space. Then, as it approaches the sun, you may see it awaken, glowing softly, trailing a luminous tail that stretches across the sky. You may imagine this journey lasting millions of years, patient and steady, returning again and again in rhythm with the cosmos. And as your breath flows gently, you may find yourself in harmony with this cycle. Quiet presence, radiant moment, gentle return. Comets are messengers, not of fate, but of connection. They connect the outer darkness with the inner warmth, the ancient past with the present moment, the small with the vast. They show us that beauty can arise from contrast, from cold ice touched by sunlight, from darkness transformed into light. To rest with comets is to rest with the rhythm of journeys, with the patience of cycles, and with the peace of knowing that even the most distant travelers return. Every system has its boundary, and the solar system is no exception. Beyond the familiar planets, past Neptune and Pluto, lies a realm that feels more like a threshold than a place. It is the outer edge, the quiet frontier where the known gives way to the unknown, where the sun's influence begins to fade, and where icy bodies drift in patient orbits. This edge is not sharp, but gradual, marked by two regions, the Kuiper Belt and the Oort Cloud. To reflect on them is to reflect on distance and endurance, on the gentle boundary between home and the deep expanse of interstellar space. The Kuiper Belt begins just beyond Neptune, stretching outward for billions of kilometers. It is a ring-shaped region, similar in concept to the asteroid belt, but far larger and composed mainly of icy bodies. Here move countless fragments of rock and ice, remnants from the early solar system preserved in cold silence. Dwarf planets like Pluto, Haumea, and Makemake belong to this region, circling the sun in wide, tilted orbits. The Kuiper Belt is not dense. Its objects are scattered across vast distances, each orbiting quietly, rarely encountering another. To imagine it is to imagine a wide, dark plain scattered with lanterns of ice, glowing faintly as they reflect distant sunlight. These bodies are ancient, untouched since the formation of the solar system. Their frozen compositions preserve the chemistry of the early days, like capsules of memory drifting in space. By studying them, astronomers glimpse conditions from billions of years ago. The Kuiper Belt, then, is not only a region of space, but also a library of beginnings, holding knowledge in silence, waiting patiently to be read. To reflect on this is to feel the depth of time, not centuries or millennia, but epochs stretching back to the solar system's birth. Farther still, beyond the Kuiper Belt, lies the Oort Cloud. Unlike the belt, which is shaped like a ring, the Oort Cloud is thought to be spherical, surrounding the solar system in all directions like a shell. It may contain trillions of icy bodies, so distant that completing a single orbit can take millions of years. These are the reservoirs of long-period comets, silent wanderers disturbed occasionally by the gravity of passing stars or the tides of the galaxy itself. When disturbed, a body begins its long inward journey, and after eons, it may appear in the inner solar system as a comet, trailing light across our skies. The Oort Cloud is theoretical. No spacecraft has reached it, and no telescope has directly observed it. Its existence is inferred from the behavior of comets and the structure of the solar system. And yet, even as an unseen frontier, it shapes our imagination. To think of the Oort Cloud is to think of a boundary that is more than distance. It is a horizon, a gentle fading from the warmth of the sun into the broader sea of the galaxy. The scale of these regions is almost beyond comprehension. Light from the sun, which takes only 8 minutes to reach Earth, needs hours to cross the Kuiper Belt. To reach the Oort Cloud, light may need more than a year. At such distances, human measures lose meaning. What remains is the awareness of immensity, of space so vast that time itself seems different. And yet, within this immensity, there is calm. The Kuiper Belt and Oort Cloud do not rush. Their bodies move slowly, their cycles measured in centuries and millennia, their rhythms unhurried. Culturally, the outer edge of the solar system has always held symbolic weight. It represents the boundary between the known and the unknown, the map's edge, the place where exploration gives way to mystery. For ancient navigators on Earth, the horizon was a line of possibility. For us, the Kuiper Belt and Oort Cloud are horizons of a larger kind, reminders that our solar system is both complete and part of something greater. They mark where the sun's family ends and the galaxy begins, where belonging shifts into openness. Spacecraft have begun to approach these regions. The Voyager probes, launched in the 1970s, have crossed beyond the influence of the solar wind, entering interstellar space. New Horizons, after flying past Pluto in 2015, continues deeper into the Kuiper Belt, visiting icy bodies never before seen. These missions are like quiet scouts, extending our reach into the outer dark. Their signals take hours to reach Earth, faint whispers across distance. And yet, they remind us that even the farthest places can be touched by curiosity. The outer edge also shows us that boundaries can be soft. There is no clear line where the solar system ends. Instead, the sun's influence fades gradually. Its gravity stretches far, its light even farther, but at some point, the pull of other stars begins to balance it. This blend, this overlap, is gentle. The solar system does not stop abruptly. It blends into the galaxy like dusk blending into night. To reflect on this is to see that endings are rarely sudden. They are transitions, soft shifts into something. Broader to imagine the Kuiper Belt is to imagine frozen worlds circling slowly, glowing faintly in reflected light. To imagine the Oort Cloud is to imagine a vast sphere of icy bodies, too distant to see, but patient in their endurance. Together, they form the outer skin of the solar system, protecting and defining, yet open to the greater universe. They are boundaries, but they are also bridges, connecting what is near with what is beyond. As you breathe gently, you may picture the solar system expanding outward from the sun, past Mercury, Earth, Jupiter, Neptune, and beyond Pluto, into the Kuiper Belt, and farther still into the Oort Cloud. Each step outward is slower, softer, quieter, until at last the stars of the galaxy take over. The journey is not abrupt, but gradual, a fading into silence. And in that fading, there is. Calmed out the outer edge of the solar system is not an end. It is a threshold. The Kuiper Belt and Oort Cloud remind us that beyond every boundary lies continuation, beyond every horizon lies space, and beyond every silence lies presence. They are the guardians of distance, the keepers of beginnings, the messengers of possibility. To rest with them is to rest with patience, with openness, with the peace of knowing that even at the farthest reaches, there is beauty. Thank you for spending this quiet journey with the Sleepy Brain Dose. As we leave the solar system behind, you may let your thoughts fade into stillness, carried by the same calm rhythm that guides the planets. It is enough now to rest, safe, steady, and at peace. When you are ready, you can drift into sleep, knowing the cosmos continues its gentle motion. Good night, and may calm science always be a soft companion to your dreams.